watch the league?
No, it's like you can catch it on video.
Nick, wait, that's the funniest show on TV.
Best ever.
Oh, what?
What's your name before he
Don't do it, John.
I was like, on phone.
And she's wearing her white bathroom.
The big guy in the wheelchair. Wait.
Oh yeah.
Because I can't walk.
You take them like, and then like all the guys like driving like up the plane and dropping it in the office.
Piano hits him and it's like,
Why? They all been studying all these? Yes. I'm so excited. I want to see how you look up one. Emily.
Seth Rogen?
Yeah.
Alright, so let's go ahead and begin.
Seth Rogen.
Okay, we just wrapped up chapter 7. We are going to skip ahead to chapter 13. We will come back to the chapters that we are skipping. But the reason we're going to jump ahead to chapter 13 is in about a month and just a little over a month. The juniors will be taking the ACT and MME. And there is more trig on the ACT and MME than there is the stuff in the chapters 8 to 12. So we're going to jump ahead and hit the trig before you take that, and then we'll go back and get back to the stuff that we're skipping. The trig doesn't depend at all on those other chapters. So we're just going to hit it out of order a little bit to help out reviewing for those tests coming up for the juniors. Chapter 13 should be a review of trig that was learned in geometry if you took geometry here with us. I'm going to teach it as if you're seeing it for the first time, but hopefully some light bulbs will turn on and thinking, oh yes, I remember seeing this before. But we will do 2 chapters of trig. We'll have chapter 13 and chapter 14. Chapter 13 again should be pretty much review. Chapter 14 will be all new trig stuff. The way we have our trig curriculum set up here is different than a lot of schools. Some schools actually just have a class called trigonometry. It's a semester long and you just study trig in that semester. We do a little bit in geometry. And then we kind of spiral up. So in Algebra 2, we redo what we did in geometry and add to that. And then if you go into pre-calc, you'll redo what was done in here and then add to that. And so it just kind of keeps building a little bit because trig is something that sinks in the better with more exposure. So that's why we hit it and hit it and hit it again as we keep on progressing through our classes. So that's why some of this may be familiar to you. But here we go. So we're going to start with first right triangle trigonometry, and then we'll go into some trig that works in non-right triangles. In a right triangle, we have one right angle and 2 angles that are not right angles. We never focus on the right angle. There has to be a right angle, but we never want to focus on the right angle. So what we do then is we pick one of the 2 acute angles in the triangle and say that's where I'm going to focus. Okay, we use a Greek letter called theta, which is an O with a little line in it, and say that's the angle that I'm going to focus on. Then we label the sides of the triangle according to the relationship with that angle. So the opposite side is directly across the triangle from theta. Adjacent as a word means next to. Like my classroom is adjacent to Mrs. Nini's classroom. It's right next to it. So the adjacent side is the side that's next to the angle. Now technically there are 2 sides that are next to that angle, but one of them is already a special thing because it is across from the right angle, which makes it a hypotenuse. Okay? So the hypotenuse is always across from the right angle. The opposite is across from the angle that we're focusing on. And then the adjacent is the one that's next to the one we're focusing on that's not the hypotenuse. Okay, so we label the three sides of the triangle according to the angle that we are focusing on. We cannot place our focus on the right angle because then the opposite would be the hypotenuse, and that leaves us with too many things on one side and not enough on the other sides. Okay, so you can't ever focus on the right angle. Focus on one of the other two and label the sides according to their relationship with that angle. There are 6 trig ratios. Today we are going to just focus on the first 2 rows of this chart. The bottom 2 rows are true, but they're just not something that we're going to use today. We're going to focus, oops, I'm going to highlight the third one. Just focus on the first 2 rows here. They show the relationships in the sides of the triangle. So SOHCAHTOA is a memory trick that a lot of math teachers use. It works great if you can remember how to spell it. If you can't remember how to spell it, it's no good to you because it is all in the spelling of that word. So SOHCAHTOA tells us about the 3 main trig ratios. So the first one is sine. Okay, it's abbreviated SIN, but we call it sine. Don't call it sin. That drives me crazy. Okay, it's sine even when it's abbreviated. Sine is opposite over hypotenuse. So in that triangle where we label our sides, one of them we called the opposite and one of them we called the hypotenuse. So sine takes the opposite side and divides by the hypotenuse side. Cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So then SOHCAHTOA spells out those relationships. Sine, opposite hypotenuse, SOH. Cosine, adjacent hypotenuse, cosine, CAH. Okay. Tangent, opposite adjacent, TOA. So if you can remember how to spell it, that's a great thing to do. If you can't remember how to spell it, make up a story that goes along with the letters. A lot of math teachers use the story. Oscar had a heap of apples, which skips the S, C, and T, but spells in the other parts of that. Okay, or make up your own story. Whatever's going to work to remember those 3 ratios. The other 3 trig ratios are the reciprocals of the first 3. Reciprocal means flip them over. So when we flip over sine, we call it cosecant. CSC is its abbreviation, but it's cosecant. And that just takes sine and flips it upside down. Okay, so it becomes hypotenuse over opposite. We take cosine and flip it over and call it secant. So it becomes hypotenuse over adjacent. We take tangent and flip it over and it becomes cotangent. So that becomes adjacent over opposite. A lot of students mess up what we call sine and cosine when we flip them over because they want to match up the cos. Okay? Sine goes with cosecant and cosine goes with plane secant. Okay? Each pair needs 1 co to it. Right? You cannot fly a plane with 2 co-pilots. You need a pilot and you need a co-pilot. Okay? Probably not a good idea to fly a plane with 2 pilots either because then who's in charge? Okay? So each pair needs 1 co and 1 plane. So sine goes with cosecant and cosine goes with the plane secant. Okay? Usually tangent and cotangent aren't a problem for students. And those other ones, make sure each pair has 1 co to it. Okay? Those last 2 rows of the chart we'll hit as we come back to some other stuff later on in the unit and the relationships of how those 6 trig functions relate to each other. Today we're just going to focus on how they relate to the sides of the triangle. There are 2 special triangles that need to be memorized. They are 30, 60, 90 and 45, 45, 90 triangle patterns. Mine's missing some information here, so I think it should be in yours. In our 30, 60, 90 triangle, we're going to say that the small side has a value of 1. The hypotenuse is twice of that length, and the longest leg across from the 60 is square root of 3 times the length of the shorter leg. Okay? So 1, 2, square root of 3 is a pattern. Now that doesn't mean that every 30, 60, 90 triangle you make has lengths of 1, 2, and square root of 3. But they are multiples of those lengths. So that I could have a side that I could say was x, and then the hypotenuse would be twice of that length, And the longer leg would be that length times the square root of 3. Okay, so that we can blow up and shrink down the triangles, but they always still follow that pattern of 1, 2, square root of 3. Likewise, our 45, 45, 90 has a pattern 1, 1, square root of 2. Again, they don't always have to be 1, 1, and square root of 2, but they always follow that pattern so that the two legs will be the same and the hypotenuse will be square root of 2 times as long as that. These two patterns are going to be extremely important to have memorized by lesson 3 for next week. So we'll use them in today's lesson, but making sure that you know those by lesson 3 will make that lesson a whole lot easier next week. Okay, our first type of problem asks us to evaluate the 6 trigonometric functions for the angle theta in the triangle. Now my theta is missing, but on your sheet it shows that theta is the top angle here. So we need to start by labeling the 3 sides of the triangle according to the relationship with theta. So the hypotenuse is already labeled. What kind of a side is 4? The opposite. And so then 3 would be the adjacent. Okay. So we want to start by labeling the 3 sides according to the relationship with theta. Opposite, adjacent, hypotenuse. We also need to know how big all 3 sides are. So we're given a 3, we're given a 4, we need to find the other side. How do we find the third side of a right triangle? Pythagorean theorem. A squared plus b squared equals c squared. When using the Pythagorean theorem, the biggest mistake that students make is doing thing we know squared plus thing we know squared equals thing we want to know squared. And always putting your variable in the c position because it's easier to solve that way. C has to be the hypotenuse. Whether that's what you want to know or not, C is the hypotenuse. Right? So in this problem, that happens to be the thing we want to know. But C has to be the hypotenuse. So if you're given the hypotenuse, then that number needs to go in the C position, and you'll be looking for either A or B. So to work this out, I get 9 plus 16, which is 25. So then our hypotenuse has a value of 5. Now technically when we take the square root to solve that, we should get a positive or negative, but since we're talking about the length of something here, we're just going to say that it's a positive 5. So the question asked us to come up with our 6 trigonometric functions. So that would be sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and tangent of theta. The format of a trig equation should always be the same. You're going to have a trig name, whatever one of the 6 it is, then an angle. It might just be a theta, it might be some other variable, just like a plain x. It might be a number because we know how big that angle is, like 60 degrees. But you should always have an angle there. I'm really bad about saying that. So I'll just say like sine is something, and I don't always say my theta when I should. But it always has to be written there. Okay, so make sure you always have a trig name, then an angle, equals, and then it's going to be a fraction of 2 sides according to the SOHCAHTOA relationships. So sine is opposite over hypotenuse, so it'd be 4 over 5. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So use SOHCAHTOA to come up with the first 3, and then once you have those, the other 3 are the reciprocals. So for cosecant, we just flip sine upside down. For secant, we flip cosine upside down. For tangent, oops, I wrote tangent twice. For cotangent, we flip tangent upside down. Okay, so for the first 3, SOHCAHTOA. For the other 3, flip over the first 3. Questions? Right, find any missing sides of the triangle using Pythagorean theorem. Label the sides according to their relationship with theta. And then find the 6 fractions by SOHCAHTOA and reciprocals.
How did you get the 5 from the hypotenuse? Was it just-
Pythagorean theorem. So that a squared plus b squared equals c squared.
Okay.
So on this one, we're going to need to do that same thing because we don't know all three numbers. But this is where we have to be really careful that we set up the equation appropriately because this time we know the hypotenuse is 13, so that has to be c. Then of the legs, it doesn't matter which one we call A or which one we call B. But we're looking for one of those leg pieces. C has to be the hypotenuse, it has to be 13. This is the biggest mistake that students make with the Pythagorean theorem is putting just everything we know on one side and solving for the other one. Make sure the hypotenuse is always C. Okay? Go ahead and solve it out for that missing side. Label the sides, come up with your trig ratios. That theta, again, is missing on mine, but it should be that top angle there. Okay, so go ahead and complete this problem on through. Make sure
Oh, I got
that
it.
you're subtracting.
I was doing basically.
So you subtract.
Subtract controls from the top side.
Everybody should get to stick. I want another one.
Oh, my God.
I have one. I have this sticker. It's not.
125?
I got Jason's five.
It's like the eyes tell it. Jason's five. Yes, yes, sir. Yeah. You don't do A squared plus B squared equals C squared. A squared.
That's okay.
A squared. What?
I'm not.
No, it's like, what's the term? It's like, we'll say this, and
This
then
one
it's
doesn't
like,
have
Mario.
No?
Because they're separate.
So it'll be like blank, what they're-
Are you sure? Because I know you turned it in late, and this one came in late.
Well.
Alright, let's go ahead and look at this.
Or she'll choose the day before to make it all.
Okay, so finishing solving out this equation, 12 squared is 144, 13 squared is 169. Subtract out the 144, and that leaves us with b squared equals 25. So I get an adjacent value of 5. Opposite would be the 12, and 13 is that hypotenuse. So then sine of theta is opposite over hypotenuse, 12 over 13. Cosine of theta is adjacent over hypotenuse, 5 over 13. And tangent of theta is opposite over adjacent, 12 over 5. The other three are reciprocals of the first. When you flip over sine, you get cosecant. So cosecant of theta is 13 over 12. Flipping over cosine gives secant, 13 over 5. And flipping over tangent gives cotangent, 5 over 12. Yes, ma'am.
If it was like 5 over 10, would you just keep it or would you simplify
You should
it?
reduce.
You
Yep.
can?
Reduce
Okay.
and simplify when possible. And in both of these examples, the third side of the triangle worked out to be a nice number. And that will not always be the case. So, for example, let's say we have this problem. Our first step would be to find that missing side of the triangle. So in finding that missing side of the triangle, I'm going to do 5 squared plus 10 squared equals c squared. That's 25 plus 100, which is 125. That is not a nice square root. Decimals are not appropriate answers. So do not take the square root of 125 on your calculator and give me a decimal as an answer. We want to simplify roots when possible. So we just finished a whole chapter about roots and simplifying roots. So when we simplify a square root, we're looking for a perfect square that goes into it. So 25 goes into 125 5 times. And this gives me 5 square roots of 5 for my third side of the triangle. Okay. No decimals, simplified square roots. So then for my trig ratios, sine is opposite, which is 5, over hypotenuse, which is 5 square roots of 5. You can simplify things that are outside with each other, but not things that are inside with each other. So I could simplify those outside 5s and get 1 over square root of 5. It's very loud. For cosine, I could do adjacent over hypotenuse. And again, you can simplify outside stuff. So that give me 2 over square roots of 5. You may, for a trig unit, leave square roots in the denominator. Okay? If you check your answers in the back of the book, they will not leave their square roots in the denominator. So we did talk about in the last unit when we were working with roots that it's considered to be kind of improper to leave them in the denominator. I'm going to allow it in the trig unit, mainly because after you find your first 3 trig functions, then you start taking reciprocals. So if I fix it from being in the bottom now, then when I flip it over, it's going to be back into the bottom again. Okay? So you may leave square roots in the bottom of your fractions. The back of the book will not. Okay? But no decimals, and make sure you simplify your square roots. So questions on what I expect for the format of your answers? Okay, our next type of problem then is to work with our 30, 60, 90, and 45, 45, 90 triangles to find missing sides. So our 30, 60, 90 pattern is that across from the 30, that's the smallest side, we should have a length of 1. The hypotenuse should be twice that big, and across from the 60, it should be square root of 3 times that big. In the 30, 60, 90, everything is based off of the small side, so if you don't know what's across from the 30, you want to find that, even if you're not specifically told to. So if the hypotenuse is supposed to be twice as big as the small leg, if our pattern between the small leg and the hypotenuse is supposed to be 1 and 2, but our hypotenuse is actually 10, then what should the small side be? 5. Right? So our hypotenuse is supposed to be twice as big as that small leg. So our small leg should be 5 then. The longer leg is supposed to be square root of 3 times as long as the shorter leg. So that'd be 5 square roots of 30. Okay. The hypotenuse is twice as long as the small leg, And the longer leg is square root of 3 times as long as the short leg. So now it's another 30, 60, 90 pattern. So again, the pattern is 1 for the short leg, 2 for the hypotenuse, square root of 3 for the longer leg. Be careful when you memorize these, students. Always put that 2 and square root of 3 backwards, okay? The hypotenuse is the double, the longer leg is the square root of 3. So if the short leg is supposed to be half the length of the hypotenuse, then what would that be? 7.5 or 7.5. Decimals are okay as long as they're really clean. Square roots are not clean decimals. That's why I said no decimals for the other answers. 7.5 is totally fine. Or if you wanted to, you could leave it at 15 divided by 2. And that's fine as well. The longer leg is supposed to be square root of 3 times as long. So it'd be 7.5 square root of 3.
On the answer, then you just want the value of x.
Yeah, I don't remember in the book if they ask you for both of them. I think they do. So I think in the book it asks you to find both of the sides. We don't know. Let's do one more 30, 60, 90 and say, for example, that my longer leg is 6 and I want to find the other two sides. So my pattern is supposed to be 1 for the short leg, 2 for the hypotenuse, square root of 3 for the longer leg. So if my longer leg is supposed to be square root of 3 times as long as my shorter leg, how do I undo that to get back to the shorter leg? Divide. So the key word there was times. It's square root of 3 times as long, so to undo times, we divide. So I need to divide by the square root of 3 to get back to that shorter leg. So that shorter leg is going to be 6 divided by square root of 3. Once again, I'm going to allow you to leave square roots in your denominator. The textbook will not. So if you check your answers in the back, this is not what their answer is going to say. Okay? But I'm going to allow it because there's enough other steps to worry about. The hypotenuse is supposed to be twice that long. So when I multiply this by 2 to get my hypotenuse, what do I get? 12 over just a plain square root of 3. Multiply together the tops and multiply together the bottoms, and that's really like a 2 over 1. Okay. Questions on 30, 60, 90 pattern? "45, 45, 90 pattern is that the two legs are the same, and we'll just call them 1, and the hypotenuse is supposed to be square root of 2 times as long. So in the 45, 45, 90, the two legs are the same, so this other leg would also have a length of 2. Again, I think the book asks you to find both of the missing sides. So the other leg would also be 2. And the hypotenuse is square root of 2 times as long. So it would be 2 times the square root of 2. And again, like the last problem, if I know the hypotenuse and I want to work my way back to the legs, what would I need to do? Divide. So we're going to divide by the square root of 2. And again, you don't need to clean up that square root in the bottom. Questions on 45, 45, 90 pattern?
Can you just go over that again?
Yep, so the two legs should be the same, whatever they are, and the hypotenuse should be square root of 2 times as long. So if I know a leg, I'm going to multiply by the square root of 2 to get the hypotenuse. If I know the hypotenuse, I'm going to divide by the square root of 2 to get back to a leg. And then the two legs will always be exactly the same. The last type of problem we're going to look at is using a calculator to solve for missing sides and angles in a triangle. When your directions ask you to solve a triangle, they mean find out everything that we don't already know. There are 6 pieces of information to know about a triangle. We can know what all 3 angles are and what all 3 sides are. Angles we name with capital letters, sides we name with lowercase letters. You'll be given 3 of these pieces of information and you will need to find 3 of these pieces of information. So in this problem, we're given angle A is 19, we're given angle C is 90, and we're given side B is 13. So we need to find the 3 missing pieces. To do this, we are going to focus on the angle that is given to us and label the other things according to the relationship with that. So what kind of a side is the 13?
Adjacent.
Adjacent. What kind of a side is A?
Opposite.
So then C would have to be the hypotenuse. If I want to find little a, I'm going to be using the opposite and the adjacent because that's what I know. I can't have 2 unknowns in there, so I can't use A and C because I don't know either one of them. So if I want to find A, I need to use A, and I need to use something I know, which is the 13, or B, or the adjacent. So opposite and adjacent is which trig function? Tangent. So tangent of angle 19 equals side over side, which is opposite over adjacent. Okay, same format every time. Trig name, angle equals side over side. So tangent we're using because it's opposite and adjacent, and that's what tangent does. 19 is our angle, equals side over side, A over 13. To solve this, what do I need to do to get the A alone? Multiply both sides by 13. And you want to type this into your calculator. We may have some modes that we need to change on calculator, so go ahead and try typing it in. We'll make sure we're all getting the correct answer here. The correct answer should be 4.47.
Nope.
So if you're getting an answer that is different than 4.47, then it may be that your calculator is in an incorrect mode. So what you need to do is press the button that says mode, which is in the top row. And on about the 3rd or 4th line down, look for the words radian and degree and make sure that the word degree is the one that is highlighted. Okay, if the word radian is highlighted, you need to change that.
How do you get to a mode?
Mode is right next to the 2nd button in the top row.
And then radian.
And then make sure degree should be dark. We want the word degree to be the one that's selected.
Can't you just define like the big B, because don't the angles
Right,
have to add
yep.
180?
Yep, so yeah, we'll need to find that one as well, yep. If you're doing this on an iProduct calculator, I don't know, Android probably has it too, but I know on an iProduct you can do it. You have to turn your phone sideways and then you get all your trig buttons, but you need to type it in backwards. So you would need to type in 19 tangent enter times 13. So it works, it's just a little bit less intuitive because you have to type it in backwards to make it work, okay? And that's fine, I don't mind if you use that on your homework, but know that when it comes to a test, I'm not going to let you use your phones on a test, so you do need to make sure that you know how to do it on an actual calculator, and you can borrow one from me if you need to, but just make sure that you're aware of that. So you can do it, you just need to type it all in backwards, so it'd be 19 tangent enter times 13. Alright, so that gives us our answer for A now. We know A is about 4.5, we'll say. To find side C, we'll use our 19 again. I like always going back to given information when possible. We could use the answer that we got for A, but if I got it wrong, then I'm going to get everything else wrong. So I would rather not use it if I don't have to. So I'm going to go back to the 13 and the hypotenuse. So which trig function am I going to use for adjacent and hypotenuse?
Cosine.
Cosine. Cosine of 19 is adjacent 13 over hypotenuse C. To solve this, we are going to multiply both sides by C. That gets rid of our fraction, but it doesn't get C alone. So then I need to divide both sides by cosine 19. On a graphing calculator, you can just type in 13 divided by cosine 19 and hit enter. On an iProduct calculator, this becomes a little bit more difficult. You will need to type in 19 cosine enter and write down yourself a little note about what that is, and then do 13 divided by that number. Okay, so typing it in backwards here takes a little bit more work. On a regular calculator, you can just type it right in order, 13 divided by cosine 19. If you're using an iProduct or a phone calculator, you gotta type it in backwards, 19 cosine enter, write down that decimal, and then 13 divided by that decimal. In the end, you should get about 13.7 as that side. We have one more piece of information to find, and it's the easiest piece of information because what did we learn in geometry about the angles of a triangle? They add up to 180. So if they need to add up to 180, we can subtract out what we have so far and see how much we have left, which would be 71 degrees left over. Okay, so no trig required to find that third angle. You can just subtract out from 180 to find the third angle. Questions? Okay. Let's skip over this last example here and go to the homework and make sure again that I have been clear about my expectations for how I want your answers on the problems. So again, remember, no decimals for square roots. Simplify square roots. Leave them in the denominator. So the only time that decimals are appropriate answers if it's something nice and clean like 7.5, that's not a problem. Or in these last types of problems where we're specifically estimating with a calculator, then decimals would be appropriate. But otherwise, especially on that first group of questions, make sure that you're not typing those square roots in and getting decimals. Alright, I passed back some homework already. I got your tests to pass back. You can't correct them because grades have to be submitted. But since you didn't have the opportunity to correct them, I did curve it. It was out of 50 points. I curved it 5 points, which is a 10% curve. It's pretty generous. So that could account for not having the opportunity to make corrections. I kind of looked at what the average was, and if the average student would have done corrections, how many points would they have gotten back on corrections, and that's kind of how I figured what I thought would be fair for a curve on it. So this is a done deal, but I'll pass it back for your corrections.
You only did that too.
I didn't know like water.
Shifting. So you're gonna have to put it down. Oh, that's on the side. If it's not under the root side to side, outside the root up and down.
Yeah, and I was like,
So it's more
So opposite of hypotenuse.
and y is greater than 0. Just start with the 0 line.
12 will be in between.
that's what I, no, I just.
X should have been greater than negative pi. And then y
Adjacent over 1. HC and I.
Hey, so, wrong way. One over.
On the test, what if it's like word
Jason.
Am I?
So then we want to find a perfect square that's divided. Everyone's mad. So like 4 divided into 16 divided.
Oh, that's right, yeah.
Everyone's mad.
Oh, the score that's at the top of your test does not include the 5-point curve. So you can add 5 points to it and then divide it out, and that would give you your average.
They do it now?
Yeah, it's 10%. One whole
No.
I remember this.
I wanna know, but I don't.
I broke the thing.
I wanna get this stuck in.
I just,
I gotta be one that has like one that can't break. Thank
Do they put a little?
I got 50%, guys. Seriously, yeah.
Oh, man.
I got 50. Oh no, I didn't. That never mind. I lied. I got like a 75. I thought that.
What's your
Oh,
I thought that
I
was
know,
a
but you
good.
add 5, so that's 6.
I got
I got minus 26.
Oh, jeez.
Actually, it's not a lot.
I only got mine.
22.5 out of 50. He almost got it. I told you.
Oh,
That's
that's 2.
That's what the struggle. Well, it's not
Where am
You
I?
add 5 points.
No.
It's like 4
It was every day.
Yeah.
I fixed it. It's fixed.
Dude, you're not getting genius. Like, it'll break.
Was this at this one or the first one semester?
Yeah, it's like a 30%. You did.
You just went all your classes.
I screwed up.
And then